My handwriting is terrible. So if you can't see what I'm writing or aren't sure, let me know. I can say it out loud. Also, if I'm going too fast or you need me to go back, just let me know. This is 4 plus -4 or 4 minus 4 equals 0. For this one, a multiplicative identity, that's MULTIPLICATIV. Multiplicative, basically you're multiplying. Identity occurs when the product of any number a and 1 equals a. So if we're using a variable, a times 1 equals a. If we're using numbers, 5 times 1 is 5. So we're going to be using parentheses. We may use the dot if needed. We're not going to be using the x, just because we're going to be using the variable x and don't want to get confused with that. Yeah.
What is the next?
This one?
Yeah, what is that?
This is 5, and then there's a little dot. Multiplication, 1 equals 5. Yes. Yes. 5, and then in parentheses, a 1 equals 5. They both mean the same thing. 5 times 1 equals 5. The next one is the multiplicative property of 0. Occurs when the product of any number a and 0 equals 0. So take anything you want. It could be infinity and beyond. Multiply that by 0 is 0. Literally, it doesn't have to be the same number. Pick whatever number you want, multiply it by 0, it equals 0. Big, small, negative, decimals, doesn't matter. Variables, doesn't matter. The next one is multiplicative inverse. I'm not sure which one that is. Anyone recognize that as their ringtone? Just make sure it's on silent. So multiplicative inverse occurs when any number a over b where A and B don't equal 0 has exactly one number, some B over A, for which A over B times B over A equals 1. Now in variables, that doesn't make a whole lot of sense. Let's do numbers. Give me some fraction. 1/3 as your first. Then we're going to take that and we're going to flip it. So instead it will now be 3 over 1. If I were to multiply across, 1 times 3 is what? 3. I think you were thinking 3 times 3. That's okay. And then 3 times 1 is also 3. What is 3 divided by 3? 1. Which is why this works. So anytime we have a fraction and multiply, what it's called is its reciprocal, we flip it. If we multiply those two together, we'll get 1. And that also works for fractions that don't have 1. It's going to be 20 over 20. Now, once you see that these are the same, you don't really need to actually multiply them across. Because what's going to happen is, I can say that like 5 divided by 5 is 1, and 4 divided by 4 is 1. So you have 1 over 1, which is 1. Both ways work, but we'll get more into that later. It says commutative property. C-O-M-M-U-T-A-T-I-V-E. So the commutative property occurs when the sum or product doesn't change when the order in which you add or multiply is changed. So if I take 4 plus 3, and then I change it and say 3 plus 4, it's still the same thing. Yeah.
I know you just said it, but what does that say?
Commutative property. Same thing with multiplication. If I take 4 times 3, 12. It would be the same thing if I switched it and did 3 times 4. The order does not matter. Multiplication and addition are the only things where the order does not matter. Subtraction and division, the order does matter, so those are not commutative. The associative property occurs when the sum or product doesn't change when the order in which you group 3 or more numbers when adding or multiplying is changed. An example of that, this space is too small, so I'm going to write it right here. So if I say, let's actually do 2 plus 3 plus 5, and then I changed the grouping to 2 plus 3 plus 5. That is associative property. Or if I do this with multiplication, 2 times 3 times 5, and then I change the order to 2 times 3 times 5 on the outside, that is another example of associative property. The distributive property is the next one. T, RIB, UT, IB occurs when any number A is multiplied to the quantity of B plus C or B minus C. So usually you're adding or subtracting inside parentheses. And then A can be multiplied to both B and C, and these products will be added together or subtracted together from each other. I'm basically going to use these. So multiplying whatever is on the outside to whatever is on the inside. Usually the inside will have numbers and variables. I was going to do a subtraction one. So in this case, the 2 on the outside is positive. So when we're multiplying it to both things on the inside, whatever this sign is based on whatever the outside number is. If the outside number was negative, then both of these would be negative. Well, this 5 was already negative, but when we multiply those two, it would become positive, yes. After we do this last one, there's a couple that aren't on here that we're going to talk about. The substitution property occurs when any number A is equal to any number B, then A may replace B or vice versa. So substitution is weird because it's basically based on things that you know. So I can say that 3 plus 4 equals 7. So if I had 3 plus 4 and I made it 7, that's substitution because I know that. If I said 2 to the second power is equal to 4, that is also substitution. I'm changing whatever it was to whatever it equals. I substituted it. I know there was another one of substitution. I was trying to think of what it was. But basically, if whatever it was changes into something you know, it's substitution. There are 2 others that are not talked about as common, but one is the reflexive. You can just write this in the bottom space. I'm not going to give a formal definition right here. There is on Canvas a vocab word wall that has these words as well. You can go see what that is. But reflexive property is this. Anytime you end up with something equals the same something. You could make 50 million examples, but let's say you're solving and you get both sides to equal the same thing. That would be reflexive property at the end. Symmetric property, this kind of goes with commutative because it's basically saying kind of the order doesn't matter, but it's the same thing either way. Like 3 plus x is the same thing as x plus 3. You could think of symmetric as there's a mirror at the equals and both sides look the same. So basically this is saying it doesn't matter the way you write it, on whichever side of the equal sign, it'll be the same. Transitive is the last. So this one's a little harder because there's multiple parts to it. And this is, it kind of ties into substitution as well. So this is like, if you have, and I'm going to use this example this in a minute. If you have this problem, and let's say you also know 4 plus 4 also equals 8. We know that. Then we could say 2 to the third equals 4 plus 4. It's taking two different things that are equal to the same thing and setting them equal to each other. So I could say 2 to the second power equals 2 plus 2, or 2 times 2. There's so many different ways you could do a transitive problem. Do you have questions about any of these words or examples? Some of these sound familiar. Is there any ones that sound new? Which one? I'm just curious. Yeah. Take your phone and scan out. Okay. We're going to move on to the next page, where we actually use these properties to say what's happening. So in each step, we're looking at what happened from step 1 to step 2, or what changed. So from step 1 to step 2, what changed, and then we'll talk about what property that is. The exponent, what about it? So this exponent is no longer there. It is now 9. So if we're changing 3 squared into 9, which of your properties tells me I can do that? Okay. The substitution property. It's something I know or could calculate and find out. From this step to this step, what changed?
9 minus 9 is now 0. Correct.
What property tells me when I subtract numbers that are the same, I get a 0? Jenna?
Identity property.
Identity, is that identity or inverse?
Yeah, that's what I meant.
Which one? Is it inverse or identity? Because there's two different ones.
Identity because it's added.
So we are technically adding, but this one would be inverse because we started with the same numbers and they equal 0. If we were adding 0, that would be identity. I'm going to shorten this because I don't have a lot of space. Right out. So when they cancel each other out, that's inverse. And then from this step to this step, what happened? Yes.
It's making from 0 to
Correct. So when we get into solving and evaluating, knowing these things are happening is going to help you a lot more. Questions on that first one? Yes, Jennifer.
I don't get that too because for an additive identity, there's always a number that's like catching out. Like I just need 7 plus 0.
So anytime you add any number plus 0, it's always going to be whatever you started with. That's what additive identity is. You add 0 and you get back the same number.
Wait, I said number 2.
Oh, for like the second example?
No, I mean the second problem of the line. Wouldn't that be identity too? Not inverse?
Sorry, this one? So there, additive is just, are you adding or subtracting, multiplying or dividing? That's just the overall name for it. The inverse or identity is what you're really looking for. Are you adding or subtracting to get 0, or are you adding 0?
Adding 0.
You're adding 0. So in this, and also this might be where you're looking at. These lines are not what's happening at the line, it's what's happening next. So this line is what happened between these two, not what you're actually looking at. That might be what was happening there. Does that make sense?
Yes.
We're going to skip number 2 because I'm going to let you guys try that. We're going to go to number 3. There's a lot of stuff going on in number 3. So let's take it step by step. From this first line to this next line, what changed? All right, Priscilla. You change the 3. What property would that be? Felix. Substitution. Something we know. From that same line to the next line, what changed? Peyton. And what property would that be? It would be inverse. Would that be additive or multiplicative? Should we multiply here? Should it be additive? Think of subtraction as another form of addition, even though it doesn't say subtraction inverse or subtraction identity is similar. Right? From this step to this step, so there's 5 times 0 became 0. Which property is that? Go ahead. Multiplicative property of 0. I'm going to shorten that and multiplicity of 0. If you have space to write all of that, you can. From this step to this step, what changed? Felix.
That was 6.
Did it become 0 or did it become 1? Single 1.
Yeah, one.
Say that one more time. Multiplicative inverse. And then from 1 plus 0 to 1, what property would that be? Okay.
Additive identity.
Additive identity. Do you have any questions on how we found any of those? It may not take you the whole next 4 minutes, but I'm going to give you the next 4 minutes to try Symbol 2, and then we'll come back and we'll talk about it. I saw that there were different ones that we started with. So first, what changed from this first line to the second one? You guys can say that loud. 2 times 1 became 2. What property tells us when we multiply by 1, we get back the same thing? The multiplicative identity. So a lot of you are doing substitution because it's something you know. And this is what I failed to mention earlier. Substitution basically works for all of these properties. So we want to leave substitution when nothing else applies. That's when it works best. From this line to this line, what changed? Really just how they wrote this part. So that, there's nothing in our rules that really say to change the order like that. So what property would that be? That's where substitution is. Because we know that is the same and no other property applies there. And then from here to here, when this changes to line, what property is that? You guys can say that. Multiplicative inverse. We're going to do some real world things with properties. I feel like you guys don't have this one because I didn't update this, so we're not doing this one. Don't worry about that. But for this number 11, Nikki walks 2 blocks to her friend Sierra's house. They walk another 4 blocks to school. At the end of the day, Nikki and Sierra walk back to Sierra's house, and then Nikki walks home. My first question is, what property do you think this is? Give you a second to think about it. And I saw 4 hands. So let's see if you all thought the same thing. Clayton? Substitution? Associative, okay. Anna? So right now we have commutative and associative. Peyton, if we had other factors that could maybe do some grouping, then yes, it would be associative. This one is commutative. You'll have this one at all. That's okay. Now that we know it's commutative, let's try to figure out a way we could write this. You know she walks 2 blocks to her friend's house, and then they walk 4 blocks to school. So the total walk to school, would we be adding those, subtracting them, multiplying them, dividing them, adding them? And then on the way back, they basically do the opposite. So then they walk from the school back to Sierra's house. And then back. You could put like an equal sign in between this. It is the same thing. But that's really, it just wanted you to kind of think about it. We're going to completely skip this one, just because it's not really a good problem. Yeah, you guys don't even have that one, it shouldn't be there. I purposely, when you look at your paper, it looks like something was pasted on that box. That's exactly what I did. I pasted this onto that square. So we're going to think about these and decide are they commutative or not. So this means, does the order matter or does it not? To put on your coat and then to pick up your boots, does the order matter? No. I can put on my boots and then my coat, or my coat and my boots. It doesn't matter. To wash your clothes and then dry them, is that commutative?
No.
No, because the order matters. I knew why you all said yes. To put on your left shoe and then to put on your right shoe. Okay, so does the order matter? No. Is it commutative? I should probably specify those questions. To hang up the phone and then say goodbye. Does the order matter? No. Let's see. If I hang up the phone and then say goodbye, did they hear me say goodbye? The order matters. Putting on toothpaste and then brushing your teeth. Does the order matter? Yeah. Otherwise, you're just brushing your teeth with a toothbrush. Can you think of anything else in real life that is commutative? Felix? The order you put on your clothes. To some extent. If you're talking about like pants and shirt, that order doesn't matter. But underwear and pants matters. The order you put on socks doesn't matter if you put on left or right. Now if you're saying socks and shoes, that order matters.
What are you putting on mask?
The order you put on your mask. What do you mean by that?
When you put it on the school,
Okay. I think the order doesn't matter as long as it's okay. Putting in contacts, it doesn't, unless like one is stronger than the other, then maybe you have a hard time. I don't wear contacts, but I would assume that it's does or doesn't matter. It does matter. So that one wouldn't be commutative, but that is an example where order does matter. I mean, that's
The order you
season something. I guess that wouldn't matter. It probably depends on what it is. It says the order which you season something. If you're mixing it all together, I don't think that matters. If you need it as like a topping, then the order will probably matter. Any others? You're probably thinking before this will never apply to me in real life. Look, we just found so many examples of real life commutative property. This is a practice for you. What time is this lesson? 10:06. At the very least, I want to start the next set of notes, which is still in that notes. and then I'll give you time to practice. If we don't, if you don't get time to practice today, that'll be priority for next class. I'll give you time to practice both of these next class. If you do it while we're working or we have time at the end and then you go back and do that, that's fine. This is just naming properties. Anyone wants to stand up, stretch? You have been sitting for a little bit. You can take that minute break. I can't even find what I'm looking for. There it is. Yes. Yes. Take your phone, scan out. Now, some of you started on that page. Go ahead and find this page. So, as long as I know the gist of what you're trying to say, so this, has like probably the most vocab out of all of them, and then the others won't have as much. Some of this may be even more familiar to you. Some of these words you may have even said, like last class. A variable is a symbol, usually a letter, used to represent unspecified numbers or values. I actually forgot what the question was. I'll have to go grab my notes. An algebraic expression consists of sums and or products of numbers and variables. Sums is specific to addition, but we could also say differences, quotients, instead of products. A term of an expression would be a number, a variable, or a product of or quotient of numbers and variables. So numbers by themselves are terms. Numbers with variables are terms, more specific variable terms, but we'll get to that. And we could also say like an algebraic expression is a term. Different ways to look at that. So these just specify, so this is a variable term. A term that contains a variable, that one's redundant. The number next to a variable is called a coefficient. I never spelled this right, so it looks right.
It's right.
A term that does not contain a variable is a constant term. The numbers by themselves are constant terms. These boxes are just kind of reiterating that 2x would be a variable term because your x is your variable. You don't have to write this part, I'm just getting it from both sides. And then the 4 is your constant term because it does not have a variable. But both of them are different types of terms. Yes, Jenna. Okay. Do you want me to say them? The next line, in a multiplication expression, the quantities being multiplied are factors. And the result is the product. An expression like x to the nth power is called a power. In this power, sometimes we just call this like an exponent term. In this power, the x is our base, and the n is our exponent. This bottom part is just determining which ones are variables, which ones are constants, and which ones are coefficients. So we're going to color code this. Of these terms, which ones are variable terms? Negative 5x, 4x. Which ones are constant terms, Jenna?
A and negative 1.
And which ones are coefficients?
Oh, no.
Did you want to answer anyway? Seven, 4, and negative 5. So just the numbers in front of your variable. On the next page. When you think of the word addition, what words come to mind? What words make you or remind you of addition? Felix? Adding, and then Erica? Plus. Maybe some others. Owen? More. Kayla? Some. Lily? Positive? Most of the time that is addition. Another total. Yeah, in addition to. data
Increasing.
increasing. Some, and we have that one. Any others? Kayla?
More than.
More than. And there are also some of these change the ending, added to. Sometimes you'll see some of, increasing, increase. Trying to think of any others. Change the ending, it'll probably be up there still. Right? What about some words for subtraction? Erica, then Jenna, then Peyton. Take away. Jenna, negative. Peyton, difference. Decreasing. Decrease. Minus. Any others? Okay, subtract. Fewer.
How many more?
One more time.
How many more?
How many more? I think that one might be addition. Okay. But less and less than. Let's see, did we get all of our opposites? We have adding, subtract, plus, minus, more, less, some, different, positive, negative. Oh, I think there is one for subtraction. Decreasing, more than, less than, difference of. If you think of another one to add to it later, we can add to it. Multiplication. What are some words for multiplication? Another can double. Okay. And we'll just put ETC because double, triple, all of those. Hayden, multiply, and then Michaela times Hayden. Any others? Multiplied, multiplying, times, double, doubling, tripling. Yes. Do that one more time. Motion. That would be for division, but hold on to that. Product of your one for multiplication?
Yeah. Just of in general.
Of in general, true. If I say 3 of x or 3 of whatever, I'm still multiplying. Right? division words. CK, quotient. Some other ones. Okay. Divide, divided, dividing. Another division. Divided. Okay. You. At all. There might be an A instead of an E, I'm not sure. There's some other standard fractions. Fractions are usually division. We'll just say they are division. Any others? Yeah. So like, it depends on context, but yes. I mean, some sort of division happen. Okay. That's just specifying the fraction, so we'll just leave it as fraction, but yes. Over, like 3 over 4 would still be fraction, but there's another way to say it. Let's see. Double, we could say like half. Half is the easiest. We'll just say half. And quotient of what did I say? You come up with all the good ones. A lot of those words you'll see when we go into translating. These last 2 boxes may or may not be parenthesis phrases are usually sum of, product of, quotient of, difference of. And anytime it says those words, whatever comes after is what we're adding or subtracting or multiplying or dividing. So if I say the sum of x and 2, also these will use that word and. I'll like put that here. The sum of 2 and x is saying we're adding those 2 things together. The product of 3, wherever you see the and, that's first and second. Now some turnaround phrases, this means when you read it, you're going to think one thing, but it's really the opposite way. And this really is just for this phrase every single time. Anytime you see the word less than, whatever comes in front of the word less than goes at the end. So an example of that would be, if I say 8 less than 5, I'll just make it simple right now. That means 5 minus 8, not the other way around. So every time we see less than, whatever comes first goes to the back. We're turning it around. It goes to the end. This doesn't happen as often, but sometimes. So they'll use the word just less to confuse you to think about doing this, but that's not a turnaround phrase. That is just subtraction how it is. And then they'll use subtract it from, and that one you just have to be careful. So starting next class, your course calendar is going to be a little off. So what we do Friday, we may not get to combining like permanently, we may, but we're going to finish this before we start this, and I'll add that to the agenda. But that is all we're going to do today. I do want to say 2 things before you guys go grab your phones. If you have not done your phone code, make sure you do that. I'm going to extend your Delta Math practice because it was supposed to be due by next class, but we didn't finish them, so that's not fair to you guys. If you did not see my post about communicating how you signed in for Commutative, make sure you look at Canvas because there's a specific instructions on that.
I already logged in.
Then you're good.